Alright, so this is an example of the last type of logarithmic equation that you might see. And this one is one where you have to do a little bit more work to get it to look like this guy or to get it to look like this guy, to where you've got one logarithm by itself. Notice you've got a lot going on here. Not as easy as that guy when you have just the logarithms to drop off. So, let's get started. First thing we want to do is we want to take this -2 right here and we want to add it over to this side. That's going to take care, and I'm going to skip some lines here, that's going to take care of moving that 2 out of the way, so we're not even going to have to worry about it anymore. When we add 2 to 7, we end up with 9. The next thing I'm going to do is I'm going to talk about these two logarithms on the inside. You have two logarithms that are added together. Remember, when you have two logarithms that are added together, we can do that thing that we called condense these two logarithms together. We can condense these two logarithms together into one logarithm. Make sure that you realize when you condense them to one logarithm that it's going to be the same base still, but you have to make sure you know those properties of condensing. Go back and review the other video or look at your notes. You take the 2x and the x and you do something with them. So the log base 4 of 2x plus the log base 4 of x, when you have plus in between them, you multiply 2x times x and you get 2x squared. So that now is inside that logarithm. So that is condensing those two down to 1. Here's the good news now. Now we can take this 3 out in front here. We're going to divide it on both sides to get it to cancel out, and it leaves me log base 4 of 2x squared equals 3, because 9 divided by 3 is 3. Now this one is perfectly set up like this guy or like this guy when you're taking it and you're using the definition of a logarithm. Although this one is going to have some uglier parts to it here at the end. So we're going to take that 4 and we're going to raise it to the third power, and it's going to be equal to 2x squared. Notice I said that a little different, but it's still the same. This base raised to this exponent equals this number. This base 4 raised to this exponent 3 equals this number, 2x squared. Now 4 to the third is 64. You have 2x squared over here. Yes, this requires some stuff from the previous chapters. Luckily for us on this one, there's not another x term right here. If there was another x term right here, we would have to worry about the quadratic formula or factoring. But on this one, all we have to do is divide by 2 on both sides. That ends up giving me a 32 over here equals x squared over here. And then we take our square root on both sides. So x is equal to, remember, plus or minus anytime you take the square root. You can factor out 16 times 2 here. Remember, we did this earlier in the year where you do 16 times 2 inside the square root. The square root of 16 is 4, and you leave the other 2 on the inside. You also could get some decimal approximations for this. If you take out your handy dandy calculator and you do the square root of 32, you're going to end up with a number 5.6